Mach lines, Mach cone, Mach angle. Okay, first we can consider any solid object. Any solid object. Any solid object moving through a stationary fluid. Whenever the solid object moves through a stationary fluid, we can see pressure waves in all directions at a velocity of speed of sound. Here we need to remember three terms: source of disturbance S, small a, speed of sound, small v, fluid velocity or velocity of source of disturbance or moving object. Here these pressure waves form a spherical wavefront. Okay. Now we are going to investigate these pressure waves in incompressible flow. Pressure waves in incompressible flow. What is incompressible flow? Can you tell me the Mach number of this incompressible flow? What is incompressible flow? Incompressible flow Mach number range. Incompressible flow Mach number. Any guess? Incompressible flow Mach number. At least Google it. Incompressible flow Mach number.
Ma'am, less than 0.3.
Very good. Okay. If Mach number is less than 0.3, we can call the flow as incompressible flow. Please note it down. Whenever the liquid is under more than 1000 bar, it will become compressible fluid. But all gases, including air, can be considered as compressible fluids. Liquids that is below 1000 bar can be considered as incompressible fluid. Any liquid under less than 1000 bar pressure can be considered as incompressible fluid. Okay. In incompressible flow, source of disturbance velocity V is negligibly small compared with speed of sound. In incompressible flow, source of disturbance or moving object or fluid velocity is negligibly small compared with speed of sound. We need to remember this point. Here, sound waves are spherical waves. Spherical waves are infinitesimal sound waves are formed in all directions at velocity of sound. In incompressible flow, infinitesimal sound waves or spherical waves are produced in all directions at speed of sound. The intensity of sound waves is symmetrical. Okay, symmetrical. The distance, the intensity of sound waves, okay, is symmetrical. Intensity of sound waves is symmetrical in incompressible flow. In incompressible flow, velocity of source of disturbance is negligibly small compared with speed of sound. So spherical waves or infinitesimal sound waves are generated in all directions at velocity of sound. The intensity of sound waves is symmetrical in case of incompressible flow. Okay, we need to remember these 3 points in incompressible flow. Okay. Shall we move to the next one? Subsonic flow. Subsonic flow. Subsonic flow means Mach number is less than 1. This is source of disturbance. Object is moving with a velocity of v. Okay, sound waves in all directions. In subsonic flow, velocity of source of disturbance is less than speed of sound. Here also we can see sound waves in all directions. Sound waves in all directions. Sound waves in all directions at a velocity of speed of sound. But intensity of sound wave is not symmetrical. Okay, intensity is not symmetrical. Intensity of sound wave is not symmetrical. In previous case, we can see sound waves in all direction with uniform strength. But here, intensity is not same everywhere. We can see sound waves, okay, closely packed ahead of the source of disturbance. But behind the source of disturbance, we can see sound waves with less intensity. So intensity of sound waves is not symmetrical. If you compare incompressible flow and subsonic flow, sound waves, you can understand this common point. Common point. Sound waves are ahead of the source of disturbance. Sound waves are ahead of source of disturbance. That's why we are hearing some warning about the object heading towards us while walking on the road. This is applicable to subsonic flight also. But this is not true in case of supersonic flow. After hitting, only we can realize something is coming towards us. In subsonic flow, including incompressible flow, we can get some pre-warning about the obstacle in our path. So we can take either left or right to avoid accident. This is not true in case of sonic flow and supersonic flow. Okay, I will explain you now. Now we understood. In subsonic flow, velocity of source of disturbance or velocity of fluid or velocity of moving object is less than speed of sound. Sound waves. Sound waves are pressure waves only. Pressure waves are generated in all directions. These sound waves travel at a velocity of sound, but the intensity of sound wave is not symmetrical. Okay. If you check subsonic flow and incompressible flow, we can get one common understanding. In subsonic and in incompressible flow, sound waves are ahead of the source of disturbance. So we can get some pre-warning about the object heading towards us. Okay, we can do some rearrangement in order to avoid accident or anything. Next, we can see sonic flow. What is sonic flow? What is sonic flow? Any guess? What is sonic flow?
Ma'am, m equal to 1.
Very good. M is equal to 1. Mach number is unity. This is source of disturbance. These are the sound waves. The object moving in this direction with a velocity of v that is equal to speed of sound. Here we can see two zones, zone of silence, zone of action. These two zones are very important. Zone of silence, zone of action. Okay. See this diagram. Any guess? Can you tell me something about the sonic flow? See these sound waves in sonic flow condition. Here object is moving at a velocity of speed of sound. V is equal to A. Okay. Can you tell me something about the sonic flow behavior? See the diagram. Try to answer me.
And this is concentric circles. Because it's joined at one
So
point.
concentric circle means a common center point, no? Okay, see the diagram carefully. Any guess? This is not concentric circles.
Ma'am, here object comes first and then the sound wave comes.
Okay. Okay, see the diagram. Here velocity is equal to speed of sound. Here sound waves exit, all sound waves exit at the source of disturbance. Okay, we can't see any sound waves ahead of the source of disturbance, ahead of the moving object. Okay, uh, sound wave intensity is not uniform, but we can't see any sound waves ahead of the object. We can see sound waves, okay, uh, behind the source of disturbance. This is the observation. No sound waves ahead of source of disturbance. All sound waves exit at the source of disturbance at a velocity of speed of sound. Okay, next we can see two zones, zone of silence, zone of action. There is no sound wave ahead of the source of disturbance. That's why this zone is known as zone of silence. But we can see pressure waves or sound waves in the zone of action. In zone of silence, there is no sound wave, whereas in zone of action, we can see pressure waves or sound waves. Okay, please note this one. No sound waves or pressure waves in the zone of silence, that is placed ahead of the source of disturbance, whereas in zone of action, we can see pressure waves or sound waves. This is about sonic flow behavior. In incompressible flow, we can see sound waves in all directions with uniform intensity. In subsonic flow, we can see sound waves in all directions with non-uniform intensity. In sonic flow, we can't see sound waves ahead of the source of disturbance. We can see sound waves, okay, from source of disturbance, not ahead of the source of disturbance. Okay, next point. Supersonic flow. This is very important. Supersonic flow. This is source of disturbance. Okay, object moving with the velocity of, v. Straight line. In every case, moving object moves in a straight line. We need to remember this point also. Moving object travels in a straight line path. This is source of disturbance moving with a velocity of v. Okay, here we can see sound waves. From center of the first sound wave, we can start second one. Okay, from the center of the second wave, we can start third one. One, two, three. Okay, we need to draw tangent by connecting these circles. This is known as Mach wave or Mach line. Okay. Supersonic flow means Mach number is greater than 1. Okay, here source of disturbance velocity is greater than speed of sound. Okay, first point, in supersonic flow, the source of disturbance velocity is greater than sound velocity. Okay, here we can see sound waves in this manner. This is not like previous case. Okay, here we can see different lines. Okay, here we can see different terms also. Mach wave, Mach line, Mach cone. I will explain you one by one. First, I like to explain about Mach cone. Mach cone. Tangents drawn from point S. Tangents drawn from point S or point of source or source of disturbance on the spheres define a conical surface. Tangents drawn from point of source or source of disturbance on the spheres define a conical surface. Okay, define a conical surface referred to as Mach cone. The region inside the cone is called zone of action because we can see pressure waves only in this zone. The region outside the Mach cone is known as zone of silence because of absence of pressure waves or sound waves. Mach cone means tangent drawn from source of disturbance on spheres. Here we can see two zones using this Mach cone. The region inside the Mach cone is known as the region inside the Mach wave or Mach line or inside the Mach cone is known as zone of action. The region outside the Mach cone is known as zone of silence. Okay. Can you understand Mach cone definition? Tangent drawn from source of disturbance on spheres define a conical surface. Okay, this is known as Mach cone. Can you able to understand? Here also we can see sound waves behind the source of disturbance. We can't see any sound waves ahead of the source of disturbance. The region from source of disturbance, tangent drawn from source of disturbance on spheres. Spheres means spherical wave or sound wave. form a conical surface. This looks like cone, referred to as Mach cone. Can you able to understand? Can you able to understand?
Yes, ma'am.
Okay, next one is Mach lines or Mach waves. Okay, we can see Mach waves, Mach lines in many places. Even in shock wave topic, we can see Mach lines. By seeing this diagram, we can understand Mach line means the lines at which pressure difference are concentrated. The lines at which pressure difference is concentrated and which generate cone is known as Mach line or Mach wave. Okay, we can see pressure difference only on this Mach line. We can't see pressure difference. Okay, outside this Mach line or Mach wave. Because of pressure disturbance only, we can see the sound wave formation. So the line at which pressure difference is concentrated and form a Mach cone is known as Mach line or Mach wave. This is Mach line or Mach wave. These two boundaries are Mach line or Mach wave. Okay, next one is Mach angle. Mach angle can be represented by alpha. In some textbook, they used this symbol also. Mach angle. Okay, we can use this symbol, Mach angle. In the upcoming topic, they used mu. So we can follow the same now onwards. Mach angle mu. Sine inverse of 1 by m. Sine inverse of 1 by m or sine inverse of speed of sound by velocity of source of disturbance. Speed of sound upon velocity of source of disturbance or velocity of fluid or velocity of moving object. Okay, angle between Mach line, angle between Mach line, angle between Mach line and direction of motion of the body is called Mach angle. Angle between Mach line and the direction of motion of the body. Okay, see here. Radius is A. Okay, so we can consider this is A. This is A. This is V. So sine mu means A by V. A by V. So Mach angle mu is equal to sine inverse of A by V or sine inverse of 1 by m. Okay, one more question. Sometimes they will give speed of sound value or temperature value. Okay, and the velocity of the object will be given. We need to calculate Mach angle. Okay, Mach angle means angle between Mach line and motion of the body. Okay, today we discuss about sound waves in incompressible flow, subsonic flow, sonic flow, supersonic flow. Okay, in supersonic and sonic flow, we can't see any sound waves ahead of the source of disturbance. Okay, after hitting aircraft or any object at supersonic speed only, we can realize, okay, these obstacles are heading towards us. This is the drawback in supersonic flow. But in subsonic and incompressible flow, we can get some pre-warning with the help of sound waves. So we can take either left or right in order to avoid accident. This is the conclusion. In supersonic flow, we can see various terms like Mach wave, Mach line, Mach cone, zone of action, zone of silence. Mach cone is nothing but tangent drawn from source of disturbance on spheres form a conical surface. This is referred to as Mach cone. The lines that form a Mach cone is known as Mach wave or Mach line. Mach angle means angle between Mach wave and velocity of moving object. Okay, next I like to introduce isentropic relation. Isentropic relation. It is applicable to isentropic flow. Isentropic flow in which heat transfer is zero. Heat transfer is zero and we can't see any irreversible effect because of friction, thermal conduction and mass diffusion. Okay, please note down this equation. T naught by T is equal to 1 plus gamma minus 1 by 2 m square. T naught means stagnation temperature. Okay, T, static temperature. Okay, gamma, isentropic index. That is equal to Cp by Cv. Specific heat at constant pressure upon specific heat at constant volume. P naught by P is equal to T naught by T whole power gamma by gamma minus 1. Rho naught by rho is equal to T naught by T the whole power one by gamma. Okay, we need to remember. One by gamma minus 1, I guess. P naught by P that is equal to T naught by T power gamma by gamma minus 1. Rho naught by rho is equal to T naught by T whole power 1 by gamma minus 1. Specific enthalpy, static enthalpy. H is equal to Cpt. Stagnation enthalpy means H naught is equal to Cpt naught. Stagnation enthalpy H naught is equal to Cpt naught or A square by gamma minus 1 plus half V square is equal to half V max square is equal to A naught square by gamma minus 1. Okay, next one is Crocco number. Crocco number. Crocco number CR is equal to V by V max. Okay, try to remember everything. And Cp is equal to gamma R by gamma minus 1. Cv is equal to R by gamma minus 1. Okay, please note down this equation. Okay, these are important equations for isentropic flow. Crocco number CR. Okay. Okay, one more assumption. Stagnation temperature and stagnation pressure remains constant. Stagnation temperature and stagnation pressure remains constant. Okay, we need to remember everything. Isentropic flow in which Q is equal to 0, reversible. Reversible means there is no irreversible effect because of friction, thermal conduction, and mass diffusion. Okay, we need to remember this equation. Okay, or you can remember like this. P naught by P is equal to rho naught by rho the whole power gamma, that is equal to T naught by T the whole power gamma by gamma minus 1. Okay, you can remember anything. Okay, I will send you all the materials. Okay, next class we can solve the problem. Thank you. Do you have any doubt? Do you have any doubt? Okay, first we simply studied about speed of sound. Now we understood sound wave in different flow. Okay, why we can't hear any pre-warning about the obstacle in supersonic flow path, because sound waves, everything, okay, are seen behind the source of disturbance, behind the moving object. So we can't get any pre-warning. Okay, after hitting only, we can see some supersonic, some object traveling at supersonic flow, heading towards us. This is not true in case of subsonic flow. Okay, this is the observation from today's lecture. I will send you, okay, I will do some modification. I will send you the equations. I will share in the Google Classroom. You can go through the equation. Next class, we will solve 1 or 2 problems on isentropic relation. Thank you.
Excuse me, ma'am.
Hi, Simran, tell me, Simran.
Ma'am, is Mach number, Mach lines, or Mach angle exist only in supersonic flow?
Yes. Yeah, we
Okay.
can see. Yeah,
In other case, it is not
it
exist.
is not there.
Yes, ma'am. Okay, ma'am. Thank you.
Nice question.